Good morning. My name is Mackenzie Vadas, and for my lab experiment 9, acid and base titration 1, I will be focusing on setting up and conducting the experiment, and for my example, I will be using hydrochloric acid and sodium hydroxide base in the form of pictures. So our chemical reaction is going to look like this. We have our hydrochloric acid, and then we have our sodium hydroxide as a base, and this is a neutralization reaction, so we will have sodium chloride, which is unreactive, and H2O water. So our first step is to prepare the acid solution. So we want to weigh out the desired grams, add the desired milliliters of deionized water, and water is added by a volumetric pipette and pipette bulb. Now the reason we use deionized water is because it does not have, it cannot conduct electricity. So we will be using hydrochloric acid, and the reason it's in the form of a powder is because we are going to dilute it with water. And how we are going to dilute it with water is by using an Erlenmeyer flask, deionized water, the volumetric pipette with the pipette bulb, and we will take some water and we will dilute it, and we will mix this by gently swirling the flask, and it will give us a clear solution. So the next step is to prepare the base solution, and it has very similar steps to the acid solution. So we will be using sodium hydroxide pellets, and we have to weigh it out similar to step A, and we want to make sure we keep it covered as best as we can because it is hygroscopic and it can absorb H2O vapor and dissolve itself. So this should be done in a fume hood or just make sure it's sealed. And then we will be mixing this in a beaker. We have our certain milliliters of distilled water, our pellets, and that again will give us a clear solution. So our next step is to make sure that the burette is prepared properly. So we want to make sure the burette is put in a clamp or stand and it's fitted properly so the burette doesn't fall. And then using a stemmed glass funnel, we're going to pour a few milliliters of NaOH to wash out the burette of impurities. So this is a basic setup. So we have our burette, this is in a stand or a small clamp. And then we have our flask. Now right now this flask is a waste flask because when we put our funnel and we use our NaOH to pour in, that's just going to make sure that the burette is free of impurities. So we will not be using that NaOH that was used to rinse. So that is a waste flask that will be taken away. And once that flask has been removed and we make sure the burette is closed, we will be adding in the rest of our NaOH solution. Just a reminder, if there are bubbles anywhere in the burette, we want to flick the burette like we would to agitate a test tube, or if there are bubbles right at the tip of the burette, we can allow a little bit of NaOH to fall out into a waste flask. So then, once everything is prepared properly, we will be able to do our experiment. So we have our burette. This on Google, the names were flipped, so I have changed it. We will be having our sodium hydroxide in the burette. This is our tap. This has a conical flask, and then our hydrochloric acid is on the bottom containing phenolphthalein. Now this phenolphthalein is a type of indicator, and this allows us to judge the color change when we react the sodium hydroxide with the hydrochloric acid. Now, if there is too much sodium hydroxide in the solution, this will become a very, very bright fuchsia color. Right before we reach the end point, we will see a small color change, and if we go past the equivalence point, we see a bright fuchsia color. So we want to make sure we add the 2 to 3 drops, and we want to swirl it to mix it, and then we will start adding the NaOH from the burette. And you want the initial color to change and the final color with a half drop. Again, if we do a full drop at the very end, we'll get something that looks very similar to this bright pink reaction. Now, just to go off a couple of terms, we have our equivalence point, and then we have our end point. So equivalence point is when these are equal in the reaction, and then the end point is when we see that color change or we go past that color change. Thank you for watching.